Aniket from Tarkashastra Academy. Welcome to the second session of CAT concepts, wherein we are explaining you the CAT concepts and important questions in 10 to 12 minutes. The agenda for today is a small concept of arithmetic and geometric progression, which is quite famous in CAT exam. We will be solving 3 to 4 questions of arithmetic and geometric progression, and in the description I'll be giving you the homework of which I am expecting the answer in the comment section. Let's get started with the concept of arithmetic and geometric progression, AGP. So what does our first question say? Evaluate 1 plus 4 by 5 plus 7 by 5 square plus 10 by 5 cube to infinite terms. So let us say S is equal to 1 plus 4 by 5 plus 7 by 5 square plus 10 by 5 cube to infinite terms. It is an AGP. Why? Because 1 plus 4 plus 7 plus 10. This is arithmetic progression. Correct? And this is what? 1 by 5, 5 square, 5 cube. Yes or no? So this is a geometric progression. So we have two series here. First is arithmetic progression, 1, 4, 7, 10. Other is geometric progression, where we have 1 by 5, 1 by 5 square, 1 by 5 cube, and so on. Now to solve these, what we do? We multiply this equation by the common ratio. Every time we do this, we multiply this equation by common ratio. So what is the common ratio? Common ratio is 1 by 5 and 1 by 5. Next term is 1 by 5 square. So common ratio is 1 by 5. So we multiply by 1 by 5. So 1 by 5s becomes 1 into 1 by 5. It is 1 by 5. 4 into 1 by 5. It becomes 4 by 5 square. 7 into 1 by 5. It becomes 7 by 5 cube. Yes or no? 7 by 5 square into 1 by 5 is 7 by 5 cube. Then 10 into 10 upon 5 cube multiplied by 1 by 5 will become 10 by 5 raised to 4 and up to infinity. What do we get now? If I subtract, so s minus 1/5 of s will give me 4 by 5 of s. This 1 as it is. This 4 by 5 minus 1 by 5 gives me 3 by 5. This 7 by 5 square minus 4 by 5 square gives me 3 by 5 square. This 10 by 5 cube minus 7 by 5 cube gives me 3 by 5 cube. And so on up to infinity. This, there will be a term 13 by 5 raised to 4. So 13 by 5 raised to 4 minus 10 by 5 raised to 4 will give me 3 by 5 raised to 4. That's it. Now 4 by 5s, how I can write it? It is 1 plus 3 common, 1 by 5, 1 by 5 square, 1 by 5 cube, up to infinity. This is what? This is my geometric progression. This is my geometric progression. What is the sum of infinite terms of geometric progression? It is a upon 1 minus r. So 4 by 5 of s becomes 1 plus 3 into a upon 1 minus r. So that is 1 by 5 upon 1 minus 1 by 5. The common ratio is still 1 by 5. So what we have, 4 by 5 s is equal to 1 plus 3 into 1 by 5 upon 1 minus 1 by 5 is 4 by 5. So this is gone, this is gone. This is 1 plus 3 by 4. 1 plus 3 by 4 is 7 by 4. So what we have, 4 by 5s is equal to 7 by 4, which gives me s is equal to 5 into 7, 35, 4 into 4, 16. So s is equal to 16. So we wanted to evaluate the sum of this AGP, which we took it as s, and s is coming out to be 35 by 60. Okay? The only method that we have to follow or remember in AGP is that we multiply the whole term by the common ratio. Let us try to implement it here as well. Again, this is an AGP where arithmetic progression is 1, 5, 9, 13. And geometric progression is x, x square, x cube, and so on. Okay. So let us say s is equal to 1 plus 5x plus 9x square plus 13x cube up to infinite terms. What do? We multiply by the common ratio. What is the common ratio? Common ratio of geometric progression in this scenario is x. And every time we are multiplying by x. So what do we get? xs, which gives me 1 into x as x. 5x into x will be 5x square. 9x square into x will be 9x cube. 13x into x 13x cube into x will be 13x raised to 4, and this will also go up to infinity. Next step, we simply subtract it. So s minus xs will be 1 minus x, s common. This will be 1 as it is. Then 5x minus x is 4x. 9x square minus 5x square will be 4x square. 13x cube minus 9x cube will be 4x cube up to infinity. Now, what we have? 1 common. Then 4 common. X plus x square plus x cube up to infinity. Then this is 1 minus x into s. So 1 plus 4 into, what is the sum of infinite terms of geometric progression? We have already seen the formula. It is a upon 1 minus r. So it is x upon 1 minus x. The common ratio is still x. So 1 plus 4x upon 1 minus x. This 1 minus x will go here. 1 minus x plus 4x upon 1 minus x, which is already 1 minus x into s. This gives me s is equal to, this is 1 plus 3x minus x plus 4x. So 1 plus 3x. And this 1 minus x comes down. So 1 minus x whole square. This is how you will have to do it. This is how you will have to do it. This is the sum of arithmetic and geometric progression, which we have taken as S. Okay. Now we have seen two examples where the terms are going to infinite terms. Okay. Here also it was going to infinite terms. Now let us find the sum of the series where there are finite number of terms. The process remains the same. Here the arithmetic progression is 1, 2, 3 up to 100. The geometric progression is 2, 2 square, 2 cube up to 2 raised to 100. So we take this as S, 1.2, 2.2 square, 3.2 cube up to 100.2 raised to 100. Okay, what do? We multiply by the common ratio. So we multiply by 2, we get 2s. Now 1.2 into 2 will be 1 into 2 square. Yes or no? Just multiplying by 2. It will be 2 into 2 cube. This will become 3 into 3 cube. Then there will be a term in between which will come out as 99 into 2 raised to 100. And this term will become 100 into 2 raised to 101. Yes or no? Because if this term is multiplied by 2, it will become 100 into 2 raised to 101. So simply subtracting, we get minus s. S minus 2s is minus s. We have 1.2 and 1 into 2. It is not 1.2. It is 1 into 2. Then if I am subtracting 2 into 2 square minus 1 into 2 square gives me 1 into 2 square. 3 into 2 square minus 2 into 2. 3 into 2 cube minus 2 into 2 cube gives me 1 into 2 cube. Similarly, it will go up to 100 into 2 raised to 100 minus 99 into 2 raised to 100 will give me 2 raised to 100. Then the last term will be subtracted. Yes or no? Nothing minus this last term. It will give me minus 100 into 2 raised to 101. Now, this minus s, it is 1 into 2, 1 into 2 square, 1 into 2 cube. Everything is multiplied by 1 only. No? So it is 2, 2 square, 2 cube up to 2 raised to 100 minus 100 into 2 raised to 101. This is what? This is geometric progression. Geometric progression. Sum of n terms of geometric progression is a into r raised to n minus 1 upon r minus 1. So it will be 2 into 2 raised to 100. What is n? Number of terms. So there are 100 terms now. We are going from 2 raised to 1 to 2 raised to 100. So there are 100 terms minus 1 upon r minus 1, that is 2 minus 1, minus 100 into 2 raised to 101. So this is 2 into 2 raised to 100 will be 2 raised to 101 minus 2. This is already equal to 1. So minus 100 into 2 raised to 101. But this is minus s. For that, we have to convert it into plus s. So plus s will become 100 into 2 raised to 101. This term will become positive. This term will become negative, minus 2 raised to 101. And minus 2 will become plus 2. So this is 2 raised to 101 common. 100 minus 1, this is 100, minus 1 plus 2. So this comes out to be 99 into 2 raised to 101 plus 2. This is the value of s, which we had to find out.
So I hope you have understood the concept and you will be able to solve the questions if asked in the exam. I have given you the homework in the description of the video. You are expected to solve it and post the answer in the comment section. Thank you so much. Jai Hind.